Hello all, and welcome to the Edge AI Talks. I'm Ed Doran, and I'm joined today, as usual, by Jenny Spielman. Jenny, how are you?
I'm great. How are you? Thanks for having me once again. I'm excited to listen to this talk with Texas Instruments. There was a lot happening recently. You didn't get to go to Taiwan, did you?
No, had different meetings during the
Yeah.
Taiwan, but I'm hearing it went really well. The workshops, the talks. What stands out for you?
It was really fun. I think my highlight of the trip was the Edge Impulse sponsored dinner. I think it was after day one, and
Yeah.
me and my co-author we did a little book signing, and everyone was like super excited that we had like a Mandarin version of the book as well. So that was really, really, really fun, and it was nice to connect with everyone in the community over there, especially in the Asia market. So it was really, really exciting. But I'm really excited for today's talk. What is it called again? The talk?
So today we're going to be talking with Brandon Kanter at Texas Instruments, and we're going to be talking about power. And Jenny, like this came up in Taiwan, and we're already hearing about it in the early work that we're doing for the San Diego conference, which I think is going to be fantastic.
Mm.
It's that constant conversation of how do we bring intelligence to the edge or bring AI into the real world. And so you always end up in this trade-off conversation around how do we get the computational power that we need, but still within the actual power envelope or thermal envelope that works. And so I think Brandon's going to be able to share with us some new innovations that are happening at TI, but also we can have a much larger conversation about how we make those trade-offs between the benefits of AI on the edge, but also some of the unique constraints.
Mm. Really interesting. I'm really looking forward to it. I just want to give a few reminders to the audience. Post your questions in the chat as we can get those answered live. And we'll also be able to answer questions after the talk as well. If you have any further questions, you can contact Ed or me or the speaker.
And how do they get their hands on one of those books, Jenny?
Well, you can email me or you can just email me because I can get you a free copy, a PDF.
There we go. Free copies. They can't get better than that. Why don't we bring Brandon in and we'll start the conversation? Sound good?
Yeah, perfect.
Hello.
Welcome,
Brandon,
Brandon.
thanks for
Thank
joining us
you.
today.
Thank you. Thanks for having me. I'm
That's
excited.
great. Do you want to take just a second and introduce yourself to our audience? We've got a great group online ready to ask questions, but let's start by letting them know who you are.
Yeah, absolutely. So I'm Brandon Kanter. I'm a systems manager at Texas Instruments, based in Dallas, Texas. So TI, we're a semiconductor manufacturer, making analog and embedded semiconductors for a very wide range, broad range of customers and applications. So myself, I originally from Kentucky and graduated from the University of Kentucky with my electrical engineering degree and my master's in business. And then moved to Dallas about a little over 10 years ago now, and I've been with TI ever since in various roles. Did a little bit of technical sales, product marketing, applications, and then managing an applications team, and then a small investment space business unit, and then now in the systems team. So what we do in our team now is that we focus on making sure our products, which are individual microchips that may have one or a few functions, work together with other chips across our portfolio to meet the standards, regulations, and trends of different systems and equipment. So I specifically support the energy infrastructure space, which I'm excited to talk about today.
Well, that's fantastic. And so just a quick question, should we expect any new products from you, Brandon, that are codenamed Wildcat then, based on your background?
If it was up to me, they would all be Kentucky themed. Wildcat, maybe a horse racing one, maybe a bourbon one, but then I don't get to name too many products. So yeah.
Okay, well, I think Jenny and I will vote for Longhorn and Husky respectively,
Yeah.
but we'll do what we can.
Yeah.
Great. So we're going to talk about power today. Do you want to kick us off with any sort of basic introduction on how you're thinking about power, or should we jump right into the questions?
Yeah. So power there's a lot of aspects of it. So in energy infrastructure, we're focused on really from generation to storage, and then monitoring and protection of the power. And then the conversion of that power. So there's kind of a lot of different things. You think about how energy gets from, the sun to the devices we're using today or to your car. There's a lot of steps in between, and so that's the energy infrastructure that we focus on, and a lot of different steps, a lot of different nodes, and a lot of opportunity for semiconductor and intelligence.
Okay. And do you have materials you want to share or no?
It looked like the material I was going to share. I'll share some stuff maybe at the end, but the introduction material, I think we were having some challenges getting that to come up. So but I can talk through. Happy to talk through a bunch of stuff.
No worries. So why don't we just sort of start? Do you want to start top down or bottom up? So we can either start top down at sort of the grid level and talk about the challenges there, or do we can start at the hardware level down at the iron and work our way up? Which would you rather?
Yeah, maybe tops down. I think that makes sense.
Okay. Well, your timing is perfect. I mean, we've had recent announcements from both startups and at least one major player that power is so limiting to their ability to support hyperscalers that there's an open discussion of putting hyperscale data centers in space. And at least the people I talk to at NASA and JPL, space is hard. It's a tremendous lift to get things, no pun intended, off the Earth and into the atmosphere. So that just underscores how important our grid infrastructure is to supporting AI. So if you were starting at that top level in terms of the grid perspective, how are you and how is TI thinking about our power grid and the opportunities there?
Yeah, absolutely. So there's a lot going on. First, there's just the incredible increase in demand. And there's a lot of factors for that. But there's two significant ones. It's the electrification of our cars and vehicles. And it's the data centers, which are, can consume the power of a small state, just in one building sometimes. And so those are two driving factors on the demand side. And so how do we keep up on the supply side, which solar and energy storage is really, I think, economically the answer, and where we're well positioned with our semiconductor content. But then on the distribution and monitoring and all that, and then conversion, because these data centers and vehicles, they're DC current, and we tend to distribute in AC, and so there's power. And then, but then if you have solar, you're starting with DC, so you may go from DC to AC back to DC. And so there's a lot of steps, and so how do we get more efficient about that? How do we get smarter about that? And that's where a lot of our technology comes in.
Okay. And so let's dig in there a little bit more on your technology. Yeah. Are we talking about fault detection, load balancing? Can you share a little bit more on the technical side?
Yeah, absolutely. So the way we think about it is a few different categories. So on the generation side, this is going to be mostly where we see semiconductors is on the solar and energy storage piece. So that's where you're going to have, a solar panel that's going to need to be inverted from DC to AC and for distribution on our power grid. And then the energy storage piece, so that's DC. So then again, you have some power conversion, but then also the health of those batteries and the load balancing and the want to make sure the cells are working to the most optimal way they can. And there's a lot of semiconductors around the monitoring and calibrating of those battery cells. And so that's kind of the first piece. And then you kind of have the second, which is the monitoring and protection. And that's where I think we see the biggest opportunity specifically for edge AI. And there's a lot of data, a lot of information you can extract from a current consumption signal. And that's where the edge AI piece really comes in. I'm excited to talk about that. And then on the consumption side, then you're back to maybe some power conversion. And I talked about the two big loads. It's, DC chargers or electric vehicles, and then data centers. And then then you're converting back to DC. So that is the a couple of the places that we have technology. Now, to get specific, the power conversion, we've got we have we're really focused on the efficiency of the power conversion. So microcontrollers that have very good loop control, high bandwidth, fast response for really power efficiency, and really that power efficiency is the key on the conversion side. On the monitoring and protection, it's about latency and being able to react quickly to some faults or some issues, and that's where again Edge AI is really exciting, and also preventative maintenance and that piece of it. And then again on the consumption, that's where you talk about again maybe some power conversion and also protection features there.
Okay. Jenny, did you have a comment there?
I think for me, coming from a developer relations side, I mean, this all sounds well and good, but I really want to know, like, what products is Texas Instruments involved with or putting out in order to assist the developer with analyzing, grid power consumption, and what is the value of Edge AI insights using Texas Instruments technology is what I'm really most interested about in hearing.
Yeah, so I would say there's two key technologies in this space that we're really excited about and investing heavily. The first is the NPU or neural processing unit, which is a small IP, a small core that we're putting into our embedded products. And so that our embedded products have different categories. We have connectivity products, we have microcontrollers. So if you're familiar with MSP, they're maybe M0 cores or M33 ARM cores. And then we have sort of motor control devices, so our C2000 portfolio, and that's where we're focusing. You can go up the scale, and what's cool about TI is we've got a huge breadth of devices. So we kind of start with the M0 small cores, getting to connectivity, getting to more motor control, and then you can keep going. And we have some MPUs, microprocessing unit, larger cores, multi-core, quad-core devices that also have these NPUs. And so, and we can maybe talk more in detail on the MPUs in a bit and what advantages they bring. But that's one space on the embedded side where we are investing, and we can provide a lot of value on for Edge AI. And on the second piece, and maybe unique to TI, and this is exactly the page I was hoping to share later. The second piece is the analog. And so there's one thing that's super critical about having a powerful and useful model is data. And so how do you get useful data, clean data quickly into that NPU for two things: for the development phase to have a well-working model, but then in real time as well to analyze that signal. And so we've got some really cool technology on the analog front end side to do some logarithmic sort of analog logarithmic pre-processing and to get the data that these NPUs care about quickly and cleanly. And so that combination of sort of analog pre-filtering and then the embedded neural processing allows us to meet kind of the key design needs, which again, it comes down to depending on where you are on the grid. It could be power, it could be latency, or it could be a combination of both.
Amazing. So I see this webpage here on TA's website that describes sort of the Edge AI technology that you offer. Can we walk through this a little bit, and maybe we can discuss?
Yeah.
You mentioned prior to the call that this site will change in a couple of weeks. What's coming? Can you tease us a little bit?
Yeah.
I'm also curious to know like what demo applications are available. So let's get into it.
Absolutely. So this is our one-stop shop. This is ti.com/edgeai. And this is where, and what I was saying is it's changing. It's just always changing. So we've got several teams adding more and more to this as we go. So this is a rapidly expanding and growing space. And really, when I think about Edge AI, I kind of compare it to what was, 10, 15 years ago of IoT, where it was like, what can you think you could put, you can connect any device. Are you talking about I can connect an outlet, to the internet? I can connect my refrigerator to the internet, right? And so everyone's thinking about where does this make sense? And we had this explosion in IoT. And the way I think about edge AI is very similar. I think it's going to take a combination of suppliers, designers, consumers, grid operators. Everyone's going to think about these new applications. And so what we're really trying to do here is really enable the tools to do two things. One, start with use cases or conceive some use cases. And that may be some example models, a repository of maybe data that you can start with. But then also match that at the end of the day, we're a hardware company. We're not, generally we work with open source software. And so where we make money is on the hardware. So we want to make sure we compare those models and those use cases with the optimized hardware to really allow them to run on the edge as fast as possible with the lowest power, with the minimal components and minimal cost. So that's what we're trying to do here. So here we think of at a high level 3 use cases: perception, real-time monitoring. Oh, sorry.
Sorry to interrupt, Brandon. Yeah. We actually have a question from the audience from William. Their question is related to the data. Is the data model essentially a kind of data and compute fabric that underlies and supports the NPUs at scale? Can you elaborate a little bit on that?
Yeah, and maybe if you scroll down, we might have a little thing on data collection if you keep going a bit. Here, yeah, so the train compute. So, sorry. Perfect. And so train, compile, and evaluate. So, so there's 2 things when it comes to the data, and why I say the data is so important. There's the data that you are training your model on the development phase. And that is where I think we're having a lot of learnings with our customers on how complicated that can be, because you may have a data set that you run and train on and you feel really good, you're getting great accuracy. And then as soon as you throw a different data set of a different load or a different example at it, it doesn't work. And so you can't really have enough data. I mean, it's the more data you have, the more accurate, the more valuable your models are going to be, and the more efficient they can be. And so that's on the front end, and like I said, and then on the real time on the edge, getting that data processed quickly. But to answer the question on is it kind of the fabric that that kind of allows it to work? I mean, in a sense, yes. So what our NPUs are doing are running models in the most efficient way possible, as quickly as possible, and how those models are accurate and work well is based off of how well they can take a diverse data set and have, let's say, a fairly predicted, accurate outcome across a lot of different data sets. And so in my world, that typically means different loads. And so the short answer is yes. I think that even we as TI, we're continuing to learn in this space of how important the data is and what's good data and what's not good data. How do you label the data? How do you, continue to iterate on your models? And so what we are doing is a couple things. We're providing repositories, open source repositories of data, and pointing customers to where they can get data. We also my team is developing hardware for data collection internally. So we're building repositories that we are basically enabling our customers to say, hey, if you're working with us and using our hardware, we will provide these data sets that we're collecting. And they could be just for demo purposes to say, hey, this model works. Or it could be to get them started on their development and just say, here's a data set, and we have a tool called Edge AI Studio that allows you to run those models and train those models on your PC fairly quickly. You can get started within 10 or 15 minutes, and that's where all of this data set and model training lives is Edge AI Studio.
You mentioned something pretty interesting, that TI will provide data sets, and you also mentioned providing hardware in order to achieve a data set for a certain application. Should we go back and discuss a little bit more about the applications that are some of the focus areas at TI? Or because So like data sets is a very broad term, right? Because a
is,
data set is only valuable if you're just focusing on a certain vertical. So today, obviously, we're speaking about the primary focus of energy. Are these use cases that are on the website also applicable to the energy vertical, or maybe you can elaborate?
Yeah, absolutely. So tying the Edge AI story to sort of the energy infrastructure story now, where we see the lead use cases are really on the monitoring and protection side. So and then very specifically diving into that is around circuit breakers and on the solar side. So the use case that, let's say, is the lead use case and where we see the most traction in deployment today is on arc fault detection. And that's under the real-time monitoring and control. So TI, we think of it as perception, which is kind of identifying, what is the objects in front of us, or what is sort of object detection, and kind of think of it that. Monitoring and control is mostly where we live, and then the audio side. But so this arc fault detection, what we have on the web today is centered a lot around DC. So maybe solar applications, maybe EV charging, or you might have some arcing. But AC is also really important, and we're very soon going to be launching a lot more on the AC side. Now to talk specifically about, again, where does Edge AI come in and what does TI provide from a hardware perspective? So the unique thing here is we have UL standard that in the US and in some places in Europe require circuit breakers to detect arcing for fire protection. And so that is a challenge because you can look at a current signal and see a high frequency spike and say, okay, I think that's an arc. And detecting the arc itself maybe isn't super challenging, but what is super challenging is detecting that arc and differentiating it from what we would maybe think of a good arc. So if you've got, for example, in your home, a drill, a handheld drill, or a hairdryer, a vacuum, a blender, all of these are probably going to be brushed DC motors that, and especially drills, you can look into the vents of a drill when you run it and you can see little sparks, right? That's usually the use case people can see that. And the sparks are arcing. And so that's intentional arcing from the DC motor. That's how the DC motor works. And so it's one thing to detect an arc. It's another thing to detect an arc without tripping your breaker, flipping your breaker every time you turn your hairdryer on. And that's a very unique challenge that's been solved in analog today, looking at slices of frequencies. And what TI or what we're doing with the models and Edge AI and putting that intelligence on the edge is, instead of looking at a slice of frequencies in an analog domain, we can now look at a full sort of two-dimensional picture of a wide range of frequencies over time. And then we look at that wider picture with so that's more data that can be processed quickly in an NPU, for example. Then you can much more accurately say what is, let's say, an expected arc, because it's a load that we know and we want, and then what is an arc that we don't want, that it could be from you drilled a picture into a wall and that nail hit a wire behind, and now that wire is frayed and it's arcing against the it could be a series arc, a parallel arc, and that could cause a fire. And so you want to be able to detect that accurately without tripping, like I said, every time you turn on a normal load. So that's a unique challenge, and where we see a very specific place where Edge AI makes really a lot of sense. Yeah. You want to detect those arcs quickly, and maybe a half cycle of a sine wave. So we're talking, 8 milliseconds. You want to detect it quickly. You don't have time to go push it to the cloud. You've got to detect it there on the edge, and you've got to trip quickly, but you got to do it in a way that's not bad loads. Now, to tie it back to the data, and then I'll wrap up.
No, continue. Sorry.
Yeah.
This is great.
And so to tie it back to the data, you may train on a data set in that use case, you may train it on, I mean, we literally in our lab, we are buying blenders, we're buying bad light switches, we're buying, drills and different things that look like arcs. And you train that data and you train that model, and it may look good on a certain set of data. And then you introduce a new load, and for whatever reason, that load, it can't detect it. So again, that's where the hardware comes in, where we have hardware that can label those current signatures to say what's a good load and not a good load, then feed that into the model. And then that's where Edge AI Studio takes that data and trains the model on that data set.
But I guess this is actually a really good segue into one of the members of our audience had a question, Scott. Really, I think you've already answered it, but let's just reiterate the question. Has TI partnered with vendors or provide AI ML DevOps tools for remote lifecycle management of models that are being deployed? And you've already sort of mentioned it, that the Edge AI Studio from TI is what's solving a lot of this. But if you want to answer this further.
Yeah, so we do partner with, we've got, in fact, on the Edge AI Studio page, we have a list of partners that we have in this space. And we do have the Edge AI Studio, which is for development and deployment. When it comes to remote lifecycle management, so usually that would mean some sort of, like a firmware update, where maybe you have an improved model. You deployed the model in the field, but 2 or 3 years later, you've got a better model, and you don't want to have to replace the part. You want to be able to push that new model. That's what I think is meant by remote lifecycle management. That as a functionality, again, we have the development tools to help you have that new model. We have the hardware to help you, push that model via, it could be, some Wi-Fi or Bluetooth. Regarding the remote management lifecycle piece and kind of monitoring that, we don't, let's say, have a tool specifically for that, but we have the pieces that you could put together to if you wanted to update, let's say, a firmware update and make sure that your model is improving over time. It's a unique challenge with the edge, right? Because you are on the edge intentionally, meaning that you kind of want it to live on its own, and you may push data upstream eventually, and if you have some coprocessor for some connectivity, but that sort of, how do I make sure that I'm improving over time without having to change the hardware? That's a unique challenge a lot of our customers are dealing with right now.
So I'm glad you brought that up. I mean, a lot of what we've talked about so far will catch the ears of like the CIO, right? But from a CEO perspective, I'm hearing things like more accurate fault detection, preventing downtime, which can be incredibly expensive. From that business owner perspective, is this primarily an efficiency play? It reduces your latency, it reduces your bandwidth utilization. But are there new scenarios that were infeasible or inefficient before that you can now do based on the technologies that you're putting forward?
Yeah, absolutely. So there's a few vectors here. There's sort of the technology vector, and then honestly cost. I mean, cost is everything. Anything about edge, you've got a lot of nodes, a lot of volume, which means pennies and fractions of pennies matter to these customers, because you're talking a lot of nodes, a lot of products. And so on the technology side, it's two things. So accuracy, we can talk about improving accuracy, and it does, but really what it comes down to is how big of a model. The bigger the model, generally you're going to get more accuracy. So how do you process a bigger model to get to the accuracy you want in the most power efficient way, at the lowest cost, at the quickest latency? And that's really the vectors we look at. And so what we bring on the technology side is really, it's two things. It's power and it's latency. What we see is if you run a standard model, or if you run a model without an NPU, so let's say on a standard ARM core, maybe M33, and then you add one of TI's NPUs as a coprocessor and you run that same model, we see in some cases 50 times improvement on power and latency, because of the advantages that sort of NPU brings, and that sort of parallel processing that it can do. And so that is a very clear advantage. But then the other piece of it is cost. And so you now can kind of play with a few knobs. You can run bigger models on the same processor, which maybe improves your accuracy or maybe more feature set, more differentiation. Or what's really interesting, what we're seeing customers do and say, wait a minute, with this NPU, I was on an M33 core that consumes this much power. I may be able to go to a fixed point M0 core and reduce my cost, reduce my power consumption, and still keep my same accuracy. So again, you can kind of go different vectors. You can get more feature set, more technology, maybe better power or whatever, or you can focus on cost or maybe a little bit of both. Those are the vectors that we work with our customers. And because, one of our advantages, we got a broad portfolio, but also one of the challenges, we have a very broad portfolio. So it can be challenging to figure out what is the right core in combination with the right analog to optimize. And what we're seeing is that each customer's got a slightly different, some care very, very much about power, or others maybe care very, very much about, everyone cares about cost, but maybe some care about cost more than others or feature sets. So yeah, and that's where my team and our sales team can help with that product selection, but then also we're continuing to build out TI.com to help with that.
Yeah, and it's always about trade-offs, especially in the C-suite, right?
Yeah.
And this is actually touches a little bit on, I think, Jorge's question here about deploying models and the size of those models. He asked specifically about compression techniques that can be achieved in the TI Edge AI Studio. Do you want to comment there?
Yeah, so we have a lot of quantization tools, and what we can do is, for example, we can even allow mixed quantization, so we can have a mix of fixed point and floating point in the model based off of the data stream, and there's a lot of without getting too much in the technical details, a lot of different knobs and optimizations in this model analyzer, and then in our model composer that we have that allow you to to really look at how much. So there's two things: there's training the model, but then on deploying the model, and you deploy the model, how much data do I need to achieve that accuracy? Again, it's all about more data means more compute, means more processing, and so to answer the question, yes, we have compression techniques. We have some stuff is on the web, and we'll continue to grow that, but we also have experts that you can reach out to your TI account team, and they can also help with that optimizations.
As a great follow-up question to that from Scott, they ask, when I create my model using your Edge AI Studio tool, does the model have to be statically linked to the rest of my code, or can it be built with an API to expose it, allowing for easier overall management on platforms like Linux?
Mm-hmm. Short answer is both. So you can build and kind of stay in our environment from beginning to end. And then we also we kind of call it BYOM, bring your own model. Or if you are in Linux, bring your own environment. And so you can export that model once you have some basic training, or as just to get started as a demo. You want to now start really working on developing and deploying that. You can export that into Linux or your own environment.
Great, thank you. We do have a little bit some more technical questions, and if we can't get that answered, maybe you can connect and get someone who can. But from Steve, does TI have any projects addressing neuromorphic approaches using spiking AVLSI for lowest possible power consumption in standard silicon, or are the NPUs all digital spiking or not?
Yeah, so I would say that we've got many teams working on a lot of different applications and a lot of different approaches to how we are developing our NPUs and deploying them. We've got this, TI's got a heritage of DSP, digital signal processing, for maybe 20, 30 years. And so because of that heritage, we've got many groups working on many different flavors of the NPUs in parallel. And so I would say, yeah, we can connect offline and maybe see if we've got a team working specifically on some of these approaches, but we've got several, and so that's part of the challenge we have is making sure we are keeping our page up to date with all the things our teams are working on. But yeah, we can connect and talk that more offline.
Well, maybe this is a good way to follow up then. I mean, so far in this conversation, and it's been great. The nice thing about our audience is we have everything from C-suite decision makers to people working all the way down at the iron and back again. And so far, we've touched on hardware innovation, we've touched on model innovation, we've touched a little bit on deployment, but all of that means you're working with a wide set of developers. So to Scott's question, how are you engaging with developer ecosystems, and what tools do you provide, what opportunities do you provide to engage all of that talent and all of that expertise as you work from hardware to software to systems to full business decision makers?
So on the hardware side, maybe I'll start with that. So we have again a growing list of hardware tools available. Some of which, so I would say almost all of our hardware tools, when we launch them, we offer all of the design information, so schematic, layout, the CAD files, everything that so you could take those reference designs that we do and you could go build them yourselves. Anyone can do that with any of our hardware that's on the web, and we continue to release more and more for this space. We also, with our customer base, we have we have E2E, which is engineer to engineer, where you can ask questions directly and request some hardware. And then we have our account teams that and if you have a contact with our account team, then usually our account team can work with us, and we can provide that hardware for you for evaluation. So the short answer is yes. We want to get this hardware in the hands of the customers, whether they take the design files and they build it themselves, with the bill of materials, schematic, and layout, or we can ship the boards, directly in some cases. And in some cases, we're also making these the hardware orderable, although that, takes a little bit more, let's say, development time, and we want to move quickly. So, and then as far as the ecosystems, also something that continues to grow. And what we're learning is this is such a diverse, Edge AI is such a diverse field with a lot of different applications and use cases. And so a lot of different ecosystems, a lot of different environments. And so I would say, probably the best way to figure out what we have is first to go to ti.com/edgeai. And if you're not seeing the ecosystem that you want, submit an E2E question, and we've got an engineer that will answer and say, oh yeah, we're working on this, we're going to release it in a few months, or oh, that's interesting, maybe we don't. And then if we start to see that question, a certain ecosystem, certain environment bubble up, or we get seeing more interest in it, then that's where we can engage. That's the different models that we have.
I actually think I use Texas Instruments MCUs in my early engineering courses at UT Austin.
Probably an MSP 430.
Yeah. Yep, precisely. So my question, I guess, is like, where is the university program sort of information that does TI have a university program? Is there information specifically for maybe like junior engineers to get more involved with the Texas Instruments Edge AI ecosystem specifically?
So we do have a university program. We don't have it, let's say, tailored specifically to Edge AI.
Okay.
But we do have that, and then we have sort of resources on ti.com, but we also have many universities across the country that we engage directly with. And so, yeah, we've got some stuff, but nothing. I wouldn't say a specific Edge AI university program, but that would be really exciting. It's something I would love to have in the future.
So you mentioned, pardon me, you mentioned something just a second ago that caught all of our attention. You mentioned orderable hardware. Do you want to talk to us a little bit about some of the things that you've seen and that might be interesting to our audience?
Yeah, so the main thing that we have, so if this is a great example here, if you, this is sort of our lead embedded products that we have that will have some sort of neural processing unit or some sort of accelerator on it, or it may not. It may just be something, and that's something that it's actually, we can distinguish a bit. You can run you don't need a neural processing unit to run a model. The software development is a piece. The hardware development is another. Now, if you have an NPU, they work well together, but we have a big portfolio of devices that customers are running models today without an accelerator. And so that's also an option. But what we have as far as orderable go is we have evaluation modules, or sometimes they're called starter kits, that are available on TI.com. For just about every product we have some orderable evaluation board that we provide. And then usually that will come with a user guide or design guide, and then some software tools as well. And the software tools, like Edge AI Studio, can allow you to pretty quickly, plug it in your USB to your laptop and start evaluating how these, different metrics, power consumption, latency, performance, accuracy of these different products. So that's one thing we have, is these evaluation modules that are available. And then I would say, as a roadmap thing that's not released, but that we're working on, and I can say, is that on the data collection side, these tools to help you collect, label, classify data, which is part of that development phase. That is something that's sort of phase one, is just having the design schematics on TI.com. But our longer term goal would also be to enable those as sort of orderable hardware that you could then purchase through TI.com and help you. It's one thing to deploy it on the processor or on the product. It's another thing, like I said, to collect that data, properly label it. And so really what we're looking to do is have tools that enable you across the development process, and like I said, data collection is critical.
Yep. So maybe this builds a little bit on Jenny's question about the university and Scott's question about the lowest cost TI dev boards. What would you recommend for somebody just to get started?
Yeah. So I would say, just to get started, the ti.com/AI, I would say, just from a hardware perspective, our MSP M0 portfolio is our sort of lightest, lowest cost, simplest microcontroller we have that runs a neural processing unit. It's actually really exciting if you think about AI on a spectrum. If you kind of just zoom out and look at what everyone's doing, there's some really big names really innovating on how much, on the GPU space, and how, cloud computing and how much data, and just super high end, how faster, you can get, and all that. Where we're on the other end, pulling the rope kind of the other direction, is how small, how cheap can you run an AI model? I mean, certainly for devices less than $1, we are running AI models on the edge. And so the MSP M0 portfolio is a great example of how you can actually run fairly powerful models, but on such tiny hardware, that also has, by the way, some of that analog integrated. And so you talk about just low power, low cost. That's a great place to get started, is to really kind of, you can open your eyes about how much these really small M0 controllers can do.
Yeah, a sort of a side comment, unrelated to this question's on the screen, but I do always crack myself up when I'm Googling about TI, because I'll just search like TI NPU, and I'll get like an article like this that has the longest acronym I've ever seen. No, but this device sounds great, but I cannot pronounce it.
Yeah.
So
and then there's internal.
If you had named that Wildcat, you'd be good right now.
I know, right? Yeah. And then we have internal code names that some people know and other people don't. I know it's and we've got tens of thousands of devices, literally, that and so it's a challenge even internally to be open about how just, is that a 3 in the middle or is that a 2? And it's so yeah,
No, I mean,
the broad portfolio, like I said, is our biggest strength, but it's also
Yeah.
can be our biggest challenge in many ways.
I do think all the big silicons have this problem. Like as you know, Edge Impulse got acquired by Qualcomm, and Qualcomm has the same problem. Like I'm always like, guys, we gotta chill with the acronyms.
Yeah,
Well,
exactly.
Coming from Microsoft and Google, I've been there too.
So we have another question. Yeah, a few questions from Adam. With the recent regulatory changes like the EU Cyber Reliance Act and the US Cyber Trust Mark, are you doing anything to secure the runtime operations?
Yeah, absolutely. Short answer is absolutely yes. So we've got a team dedicated to understanding the CRA, and the definition of that is not completely finalized, but we've got a team working on that. We've got kind of a methodology, if you want to call it that, or our approach, I think is fairly well understood of how we handle that. And so, of course, there's gonna be some variations product to product, but we've made a lot of progress as a company defining what that means for us and our products and classifying products. And we have more information. I think some is on ti.com, but certainly, if you're a customer, we can share that information with you. But it's evolving, and we've done stuff like this before. At one point in my career, worked on some of our what's called functional safety or safety critical applications in automotive. And an individual microcontroller isn't going, isn't a system level, and you can't verify all use cases. And you can use a microcontroller a microchip many different ways. But what we can do is we can provide data and information about what's inside the chip and how the chip performs, and you plug that into more of a system level. The CRA is really more of a system level challenge, but we can help you with providing that data. That's the short answer, but there's a lot more there, and we can provide that.
Is there like a team? Like, would it be more of like a sort of a consulting sort of to get those questions answered by TI? Would that be something that would be on a business contract level in order to get that sort of consulting to comply?
Yeah. So 2 things I would say. If you are if you're a customer buying our products, certainly we would engage with you directly on those conversations. Or if you're not sure who the TI contact is, that's a great thing too for our E2E tool on ti.com. So if you've got a specific device or application that you're interested in the CRA and what TI is doing, you could ask that, and we can provide feedback. We strive for 24-hour response time on all E2E questions. I'm not saying we always hit that, but that's what we push for.
Is this the correct E2E site? The E2E forums? Okay, great.
Yep.
Looks like it's just for everyone watching. This is e2e.ti.com.
That's right.
Nice. Well, maybe this builds on this. William has a great question about, does your team create custom edge NPU chips based on your designs, and will you be naming it Wildcat?
Up to me, absolutely yes. We would name it Wildcat, but custom edge NPU chips. So TI's approach, we do catalog devices, and we do application specific standard products, ASSPs. That is our primary focus. So when it comes true custom for like a single customer, that would be very much use case dependent, but our focus is on catalog products and application specific standard products, ASSPs.
Okay. We have time for a few more questions before we pivot forward from the audience, so we'll move that forward. We did touch briefly on security, and we always get a ton of security questions. Are there unique benefits to working with your products or taking this approach to Edge AI that you think provide that more secure for unique environments?
Yeah, so Edge AI, one of the advantages our customers talk about why they like it is the inherent idea that you're processing on the edge, which of course again improves the latency, but also means that you don't need a data stream outside of the device. And so that inherently means that if there's no data stream, there's no way to sort of hack or get into that data. And so that's one of the advantages of Edge AI. Now, a lot of our Edge AI products, maybe the model is running on a local processor and the decisions made on that local processor, but you still may have a coprocessor that's streaming out data. And so that's, certainly we have that. And I think the CRA, the Cyber Resilience Act, is helping put some definition around how can an IC vendor contribute to that, because in the end there's going to be many layers of software running on that hardware, but how can a microcontroller vendor, or how can a microchip vendor provide confidence that chip is secure? And so we do have secure IP, secure mechanisms across our portfolio. So it's going to vary depending on what the device is. But that is something we develop in-house, some secure IP, and it's going to just vary product to product. But the important thing is that we want to make sure that we can quantify that and describe what those mechanisms do and how they work, so that they can make sure the broader system is secure.
Great. And we have another question from Scott. I thought this was interesting. I didn't even know about this product, but the MSP M0 has a zero code studio. How does this connect with the Edge AI studio that TI also has?
It's a great question. So Zero Code Studio and Edge AI Studio are different tools today. But the concept is similar, which is that it's all about customer enablement. And so there is, let's say, some discussions about how these maybe would merge in the future, or how we could leverage some of the zero code concepts in Edge AI, and it's let's say similar teams working on both tools. So it's a great question. It's also something internally we're discussing. So I would say stay tuned. A lot of investment in this tool development space.
Right, and I feel like it really definitely depends on, obviously will require a lot of custom engineering work, but you can't have a computer vision project necessarily on an MSP M0, I'm guessing. Right. The thing at Edge Impulse is when we're using small devices like M0s, we can only do essentially sensor classification for things like anomaly detection. Did you hit the wall? Did the package fall over? Stuff like that. So I would assume it would require a lot of custom engineering just to make sure that the Edge AI Studio is not trying to enable people to use the wrong hardware for the wrong application, because they literally will not be compatible. So maybe we'll see some things there in the future.
Yeah. And not to get like too meta or crazy, but like one thing we're looking at, our R&D team is looking at, is AI for AI. So how can we leverage large language models to help make these tools and make the models that live on the edge quickly and easily? And so you can just think out in time. It would be great if you have a user prompt and say, build me an Edge AI model that detects arcing, blah blah blah, and then it in this size of code with this on this hardware, optimized for this hardware, right? And so that would be the dream, is to use a large language model, LLM, AI agent that then could build a model that would still need a human to validate and test, of course. But that's something that's kind of exciting, let's say, vision that TI has on this.
That's a cool vision. I think all industries in tech are heading towards the AI agent route right now. So I think it's definitely a doable dream, but requires some technical competence in order to connect all the correct data sources and make sure that it's not hallucinating, or if it's making up data on its own without your permission. So there's a lot of things to watch out for. But I think that's really,
and to that point, that's why. Yeah, exactly. And to that point is data, right? I mean,
Yeah.
you can build a model, but unless you have quality data to go test and validate that model, it's tough. And so that's one thing I think, again, where customers are learning quickly that are deploying this edge AI, and that's something we're learning. Is it's one thing to provide an example model, example code, but having a quality and quantity data set in the end is going to matter, no matter where that model came from.
Yeah. Well, maybe we build on this a little bit. We're talking about the future, and we've got a few minutes left. Looking ahead, what should our audience be thinking about? What's emerging that you think is really inspiring, or you think it's important that we start to think about now as we look forward over the next few years?
Yeah. So I kind of go back to that analogy of, you think of edge AI as the spectrum, and a lot of stuff in the news pulling it in the direction of more compute, more processing, and we're pulling it sort of on this just how small and low cost and low power can you run these models. And I think, and again, I go back to that analogy of IoT and how crazy it was that you might have outlets that you need a Wi-Fi password for, right? 10, 15 years ago. And I think that's happening on Edge AI. I think the use cases, you think about what has a microcontroller today, or just any electronics today, and how many of those use cases could benefit from Edge AI models. And it could be just super simple models that you might be able to take your, a very similar hardware, a very similar footprint, and unlock way more features and data extraction and preventive maintenance or whatever it may be. You may be able to unlock all that. Where we see a lot of traction, like I said, is circuit breakers and metering, and how great would it be if your circuit breaker or your meter can tell you that not just you've got to get your AC get your AC checked, but it can say specifically that the condenser pump or condenser motor is failing, and go get that checked out, right? I mean, and so what's exciting and forward looking is we are developing a platform of tools to enable our customers and our engineers and our developers to really think about all the different use cases that you could use Edge AI. And that's what's really exciting, is I think there's use cases none of us have thought of yet that we will see in 5 to 10 years. And that's what's really exciting about innovating on this sort of edge low cost end, is that just the use cases and where you could see it are endless. And again, innovating on features or innovating just on making things same features but lower power and lower cost. So that's what we're focused on, and that's why we're expanding our portfolio. We've got from super low end M0s to up to quad core plus higher end MPUs that could be used in autonomous driving, for example, and anything in between. And so we want to have the portfolio, and we want to have the tools, and then provide that tools in a way that easily allows our customers, which we have tens of thousands worldwide, to start dreaming and figuring out, where can I use this and where can I deploy it. So that's what's exciting to me, is I think we're going to see Edge AI all over the place, in places we couldn't think of, can't even think of today.
Yeah, it's exciting. Jenny, any final thoughts?
No, I thought this was a great conversation. Yeah, I just any final announcements or things that you want to say to the audience, Brandon, about what TI is doing?
Yeah, I would just reiterate ti.com/edge AI. We continue to expand our portfolio of products and continue to expand our portfolio of tools to enable customers, and then and data sets, and then third-party partners and environments. And if you're not seeing it today, we want that input. Like I said, probably the best way is the E2E forum. And if you've got an environment or an approach that you don't see yet, please submit it, and it'll get to the right people that are working on this, and that's how we grow together.
So, Brandon, we're about out of time, but I see there's a couple questions coming in late. Would the EDE forum be the right place for them to follow up with you in terms of things you've talked about today, or other open questions that they might have?
Yes, absolutely. That's the best way. I'm also happy to provide my contact information as well, and I can also forward specific questions to the right people.
That sounds perfect. Oh, please.
No, thank you so much, Brandon, for your. I guess today was more of a conversation than a presentation, but it was really interesting to hear about what TI is doing, and thank you for your time, and thank you, audience, for asking amazing questions as usual. If like Brandon said, if you have any follow-up questions, reach out to him and connect with him, or ask them on the eDOE support forums.
Great.